Hello, everyone, and welcome to our webinar on building scalable real-time apps with Astra DB and Vaadin. My name is Marcus. I am your host today, and with me I have Sami Koksonen.
Hi.
So, Sami, you are currently working at DataStax, but you used to work at Vaadin before, right?
Well, that's correct, yeah.
So if somebody recognizes him, that is why.
Yeah.
But that's not why we're here today.
Absolutely not. So let's focus on something else today.
Yes. So today we are going to be looking at building a really cool kind of stock data application using the DataStax platform and Vaadin as the UI. Before we get there, a couple of quick housekeeping rules. So everyone will be muted during the webinar, but you are able to ask questions during the questions panel. So if you have any questions, go ahead and ask them there, and we have some time at the end. But if we see any questions that are kind of related to what we're speaking at any moment, I might ask Sami or he might ask me.
Yep.
If there are questions that we don't know the answer to, we'll really try to get back to you on those after the webinar. So we will be sure to do that. And also, we'll send you a link to the slides and the recording within about 24 hours of us wrapping up today. Sound good?
Sounds like a plan. So
All right.
Let's start.
So the high-level agenda of what we're going to do today is just do a quick intro to Vaadin Flow, which is what we're going to be using on the UI side of things. And then I'm going to hand it over to Sami, who's going to just give us a broad overview of what all DataStax does and how we're going to use it for this application. And then the majority of today, we are going to be looking at actually building an application using Vaadin and DataStax. And then towards the end, we'll have dedicated time for Q&A. So if you have any questions, be sure to just put them in the questions panel below. All right, so just a quick introduction to Vaadin for those who are joining us from outside the Vaadin community. We are a company that helps developers and companies modernize Java-based applications and build new ones, of course. We have two different frameworks that you can use when you're building these applications. So we have Vaadin Flow, which we're using today, which allows you to build web applications fully in Java. And then we have a newer framework called Hilla, which combines a reactive TypeScript front end with a Java backend. Like I said, we're going to be working with Vaadin Flow today, and it's a pretty unique framework in the sense that it allows you to build web applications 100% in Java. So the way it works is everything is a component. So if you need a component, you would instantiate a new component, call it button. If you need a date picker, you would instantiate a date picker. If you need a grid, you would instantiate a grid. So pretty straightforward. You can look at our component library and see what component you need, and there's a corresponding Java object to that you instantiate. So very straightforward. All right, so when you have a component, you of course need to build some kind of bigger, meaningful thing out of them, like a view. So for that, we have layouts. So for instance, the basic vertical layout allows you to lay out components vertically. Horizontal layout would allow you to lay them out horizontally. And then by combining these layouts and some of the more advanced layouts, you can basically build whatever type of layout you want. You can then add a route annotation on a component to add it to to be able to navigate to it. In this case, we are able to navigate to this route with a hello path. And let's see, seems like we're missing our video feed here. All right, I will take a look at that shortly.
Something always happens.
Something always happens. So is anyone able to just confirm that you are able to hear us? Let's see here. Sorry for the interruption. Let's see what's going on here. Okay. Back in business, maybe.
Good recovery.
Yes, let's see here. We can hear you. All right, thank you, Johan. Yeah, I don't know what was going on. This is my first in-person webinar with, since the pandemic, and my studio setup is a little DIY, so pardon the interruption. Anyway, so if we get back to building apps with Vaadin, you can see that we're able to instantiate new components to build layouts out of them, and then we can add them to routes so that we can navigate to them. And finally, we can use listeners to add any kind of interactivity by listening for those events. So in this case, we're listening for the button click event, taking the input from the text field and adding that to our layout. So that's essentially the three things you need to understand about Vaadin Flow for what we're going to do today. Everything else I will explain as we go along. We are going to use a application that was built using the startvaadin.com initializer. So you can go in here and customize a app starter for your needs. And with that as a base, we can then start building out our own logic on top of that. It's going to be using Spring Boot as default, and that's perfect for exactly what we're going to do today. So if you want to take a look at that, you can find that on start.vaadin.com. All right, so over to you, Sami. You want to share your screen?
Yeah, sure. Let's see. Hopefully there's no demo effects over here. Let's take that one. Let's put that on a slide presentation mode. Yeah. So I'm gonna spend a couple of minutes just explaining what the real-time platform is. So like any application, it needs data in order that it makes some sense, and that's where DataStax platform comes into place. Then I'm gonna show also the high view of maybe the architecture to just let the audience understand what we are about to do with the code as well. And then Markus will take care of showing them the streaming and the accessing the database part from the application.
Yeah.
So let's start. Okay. There was a delay. But yeah, let's talk about the DataStax real-time data platform. And what we've done is that we have built a data platform based on open source components. It's basically serverless solution where companies then can kind of rely on the data needs from the beginning of first the pilot and proof of concept project all the way to massive scale production environments. And we are talking about maybe Netflix, Apple kind of use cases where
I think that was like one takeaway for me was that it was very easy for me to set it up using the like online admin console or whatever you call that place. But in the same sense, it wouldn't be all that different if I needed to scale that up to a much larger setup.
So we'll be showing in 5 minutes or so how to set this up, and then you have all that you need to build your application or business to become a unicorn, the next unicorn. Nevertheless, like the services, we are cloud agnostic, so you can basically choose to deploy this platform in any cloud provider of your choice. The core components of the data platform really is the database engine, which is powered by Apache Cassandra, a NoSQL database. On the streaming side, messaging side, we have Apache Pulsar, and then a important component is also providing access then for the developers and the API gateway on top of it. So those are the three main components that consist of this one. So maybe I'll jump to the next one. So actually, when we planned for this webinar, we were talking about the real-time data. But need to bring this up that in the beginning of this month, so not that many weeks ago, we DataStax also acquired Cascada, and we are about to evolve into a real-time AI cloud as well. So that brings a new, on top of this, then kind of new tools for the AI machine learning models development as well. So bringing the data in real time for those AI machine learning models, that is a really cool feature. But we are not going to focus on that today.
Yeah, good.
So maybe that's on the high level what the DataStax data platform is. And we could move on then maybe to show how that is set up. And before I'm going to do that, let's spend a little bit time on the architecture picture, explaining what we have built. So we have now built this demo application, which is basically consuming stock data.
Yeah.
And now to make it a little bit simpler for this demo, we actually are getting this source data now from the Alpha Advantage API.
Yeah.
And we are using Vaadin application to produce the stream that typically you would get from any existing data connections like Kafka Stream or something, like financial institutes have their own streaming solutions, and that would be kind of in real case that the source for this data.
Yeah, but I think like for the demo, it made a lot of sense for us to both show how you could produce data simply and how to consume it. So we combine the two into one application, whereas normally in real life, you would probably have separate apps that produce and consume
exactly
the data.
And that shows also how you can produce some valuable data for other organization parts from Vaadin application as well. So the same kind of publishing method works there.
Yeah.
So today, so that's the source. We're going to produce create a stream for Apache Pulsar or Astra streaming, I would call it. Today, we are not going to use that much of functions. You could then process those functions as well, but then we are syncing it back to the database.
Yeah.
Where in this case, we are using Astra DB, but of course, you could sync that the information then to Snowflake or other database like MariaDB or something like that, if you want to.
So I wasn't super familiar with Pulsar before we did this. Do you want to give people just a quick, like 30-second intro to what is Pulsar? How is it different from, say, Kafka, if people know what that is?
Yeah, so probably Kafka is de facto solution used today, but you could say that Apache Pulsar is a little bit, it's more recent. So it's basically built cloud native from get-go. So it means that the geo distribution of that solution is so it scales horizontally a little bit better maybe than the Kafka.
Yeah.
So there's a lot of benefits over that one as well.
Yeah. And they're both Apache open source projects. So,
yes. Yeah. I think I saw a study or a research that they were comparing contributors for both of these projects, and I think the Apache Pulsar committers were kind of growing or overcoming the Apache Kafka community. But I need to check that.
I think another thing that was really nice to me when we were working on the application was that even though we're using the DataStax platform, because we're using these underlying open source projects, they work just seamlessly out of the box with Spring Boot, which is what we're using. Yeah. So because we're using these standard building blocks, it's very easy to kind of get to or just start using them without having to like learn an entirely new way of doing things. And that was something I really appreciated from a developer standpoint.
Yeah, I don't know, maybe the video feed vanished, but maybe we can continue.
Yeah, let's. I think the sound continues to work.
So anyways, I think that this provides full flexibility for the companies to work with the data, and they can either input it from a stream and put it to the database, or from database they can do. Cassandra supports something like change data capture, so they can actually then broadcast these changes to the database through the messaging as well, and then push that forward to the third-party solutions as well. So it gives a lot of flexibility. Now we have the picture back, and Marcus is gone, but he's going to be back soon. But yeah, that's the high level, and let's jump to the Astra DB. So astra.datastax.com. I'm going to sign in now with the credentials here. I've actually joined a organization with Marcus, so we're working on the same organization. And let's start by creating the streaming. And I'm now showing how you can create a streaming tenant, and then a database, which you then later on would need in the Vaadin project as well.
Yeah.
But creating a stream is very, very straightforward. So you just created a name. Let's call it example stocks. And you can choose different cloud providers. I'm on pay-as-you-go, so I can choose whatever. We have a free tier as well that gives you like multiple tens of gigabytes of data storage and tens of millions of kind of operations, read and write operations for free. So
plenty to get started.
Yeah, I can guarantee you will not going over for if you want to try this demo on your own.
Is there any other kind of difference between the providers? Like, are there any features that are tied to one specific cloud, or is it like everything works everywhere?
There might be some minor differences, but pretty much all the features are there. So now when we are doing this kind of a connecting the streaming part with the database, it's good practice to keep then the same cloud provider and the same region when we are creating these instances.
Okay.
But let's just create a tenant. So it's just, you give it a name and choose a region for it, and you're all set, and it's already active, so it was super fast to set it up. And for the demo, and if you're working with your application, although you don't need to do it, but you could actually go to the settings and enable this auto topic creation. It means that from the application point of view, you don't need to have any topics up front created, but once your application is trying to push something into the topic, this automatically creates a namespace and then a topic for it. So it's just good for the.
And what is a topic, in case somebody
isn't
familiar with the terminology?
The terminology is that the streaming instance here is called a tenant, and within a tenant, then you can define multiple namespaces, which is more like a collection of the similar types of data. And then within namespace, again, you have topics, and topics would be now, let's call it this message bus then that you subscribe to, and then you can exchange some data.
Good.
So that's it. That's what you need from the streaming side. For the databases, let's create a database as well. So creating a database, let's take example here, key space. This is more like a schema, but of course it's schemaless, but you can say, let's use stocks here as well. I think that was using the demo instance as well. We're going to choose the same US East here and then create the database. And that's it. Pretty much this are the kind of, now you have a fully functional platform ready for application developers then to start using the benefits. And one important though, when you create the database, you can download the token details here, client ID and secret, that's a username and password, using the settings and in the properties of the application. And token is then something that you use for when you are working with the REST APIs, or kind of other forms of data. But download those to your computers, you will be needing those later on.
And there was a zip file we needed as well.
Yeah. So then once you have created this database, you can go over here. Let's use this one. And then when you go to the connect page, you can actually then, let's take Java. You can download a bundle here, which then downloads a zip file to your computer, which pretty much then handles the MTLS communication between your application and then the database.
So the zip file contains certificates and information about the connection. So this is something we need to have available, but we don't want to be putting it into GitHub because we certainly didn't do that at any point.
No, absolutely not. We did not need a fresh start.
Yes.
But good. Basically that's it, what you need from the platform side, and then it's over to coding.
So I think the next thing is like just looking at how we configure this. So if we start by looking at the application that we have, this is like I said, a Vaadin Flow application that we created using that start.vaadin.com starter. And to this, we added a few dependencies. So we added Spring Pulsar. This is a kind of upcoming project. So this is still a snapshot release that we're using here. And the other one that we needed was the Cassandra Spring Boot starter dependency. And because we're in a Spring Boot project, this is a lot like configuration driven. So what we did is we configured in all these properties that we copied over from the screen that we were just on. So again, the username and password were the ones that you downloaded. And then we have this secure connect zip file. This I added to our...
And maybe for clarity, I mean, we already created one instance just like I did, but the different name spaces, but to reduce error margin here in my webinar, we are going to use that instance.
Exactly. So that zip file I put into the resources folder here and made sure that that's in my git ignore. The settings that we have here, I actually have a local override that I've also added to my git ignore, where I actually have configured these, but I wanted to show you which ones we needed. So essentially we configure Spring Cassandra by giving the key space name, username, and password, and then we provide the name of the zip file that we have. Then on the Pulsar side, the streaming side, we again configured the service URLs and everything that we need, the tokens and so on.
And this is, by the way, I forgot to show them, but there's a similar Connect tab. Then when you navigate there, you can find all these settings from that dashboard as well.
And then finally, like Sami mentioned briefly, we're using a third-party API to fetch stock data. So the way this application works is that we have a dashboard where you can select a particular company. And when you select that company, it will start producing data into Pulsar. So it will start sending messages to that. And then we're also in the same application consuming those messages. So if we take a look at the actual code that was needed for building this, you'll see that it's actually fairly straightforward. So we are in a Vaadin Flow view called dashboard view. It's mapped to the empty route, so basically just localhost 8080. And here we essentially auto wire in two things. We have a stock price producer, which produces things, and a stock price consumer, which is for consuming.
Logical naming for the classes.
Exactly. And then we create a couple of components. So we have a combo box for selecting these stocks. And we have a chart here, which is a Vaadin chart, open, high, low, close type chart. And the way this works then is that whenever we select something in this stock selector, we have a value change listener here. If you remember, you add interactivity by listening to value changes or events in general. And for that, we call this ticker selected method. And here, essentially, what we do is we create a new chart, and then we clear the data series. And then we call this producer to tell it to produce some stock data for us. Internally, what we do here is we call that external API to get stock data. And then we publish them to a Pulsar. What's the stream? Is that the right term that I should be using here?
Yeah, to the topic.
Yeah, to a topic. Here we're using Spring Pulsar. So you will see that we have in the constructor, we've auto-wired in a Pulsar template with the right data type that we want to use. And because we had all these settings here for Pulsar, Spring Pulsar will actually take care of managing that producer for us. So we don't have to take care of connecting and disconnecting and managing threads and doing any of that. We just get this template and we send messages to it. Yeah. The messages can be essentially strings or any kind of complex data types.
Yeah, exactly. So you can define the schema for these messages.
Yeah, and that's something we
JSON in this demo.
Yeah, so we did that here. We have a bean that defines that custom schema mapping. So stock price class should use the JSON schema here. All right, so we go back here then. No, not there. So if we go back to the producer, you can see that we send these, and then that sends them over to DataStax that publishes them to the stream, and then the other part of the equation then is the consumer. So if we go back to our dashboard view, here you will see that we have the stock price consumer, and the way we're using this consumer here is that we call subscribe on it, and anytime we get a new stock price, we append just that new value that comes in to our data series. The way we've implemented this is also using Apache's the Spring Pulsar library. So we have defined this as a Pulsar listener, and because it's using the stock price type here, it knows that it is that same thing that we're listening for. So again, it's using the these topic names and producer names to match these two things together. What I'm doing then internally here is, so what I'm doing internally here then is and we lost the camera for whatever reason, but I'll figure that out. So what's happening here is whenever a new message comes in, this listener gets called, and what I'm doing internally is I'm publishing those to a sink internally. So essentially, I'm programmatically creating a reactive stream in my application. The idea being that if I have, like, say, multiple windows or clients using this application, they all don't need to separately subscribe to Pulsar, but I can kind of just deal with that locally within my application. And then this get stuck prices method that we used is just producing a flux that we can subscribe to here.
That's right.
So that way we get the flux, we subscribe to it, and then whenever new stuff comes along, we can just append that to the data series. And with that, we're able to just have this chart automatically update with the data as it's coming in.
Yeah, and maybe I could bring it up here that when you're subscribing or consuming these messages, you can, of course, subscribe with different types as well. But I think one of the cool things about the Pulsar is as well that it can promise also the message delivery and the order as well. We are using the key shared subscription type here, which means that you also get the order in the same order that it was produced. So that's good to know as well.
Yeah. And one thing probably worth mentioning here is that on the Vaadin side of things, we have added this push annotation, which means that Vaadin sets up a WebSocket for us, which allows us to be pushing data over to the browser automatically as it's coming in, which allows us to build this real-time type of application. Now, this is all fun and nice, but like, what if I wanted to somehow look at this data on a longer time period, maybe kind of look at historical data? Is there any way I could, like, save this into a database, perhaps, Sami?
Yes, I think that's possible. Thanks for asking.
Yeah.
But yeah, I could actually share my screen again here.
Yes.
Turn it off. So obviously you could do it in the traditional way.
Share your screen.
Yeah, I'll do that. Just a minute or two, like that. Right. Yeah, so of course you could do that in traditional way as well, using a program that within your application. But let's take the advantage of using the platform for this case. So now we're gonna configure and show how you can then use the stream and access that one. Like I said, we are not processing it. In more maybe advanced example, we would have that stream of stock information because it has a different tickers now.
Yeah.
All is going to the same stream. You might want to distribute those to a stream of their or topic of their own, like per symbol, and then subscribe for that for specific topic.
Yeah. And I was thinking of, like, say in this particular use case, maybe it would make sense to have something that filters out, like, abnormal values. Say, like, if the price all of a sudden jumps up or down, like, we could have a stream that only captures, like, remarkable events that we could then use to display alerts. Or
and let's take a use case. You would set a price alert, for example. You would have that as in your database. You could have a function then accessing the database entries and then triggering a new stream of alerts, which you would be then subscribing in your application, throwing notification or whatever you want. But yeah, let's see how you can put that data directly within the platform to the Apache Cassandra as well. And now we're showing that way. Of course, you could do it the other way as well, CDC. So if that would work the other way around. So if you would do some modifications in your Cassandra tables, and you would trigger then an event based on that. So then you just, again, couple of clicks away, you can trigger these and push them as streams. But
so we're using Cassandra here. Why are we using Cassandra as a database as opposed to something else? Like what types of things is Cassandra good for?
Yeah, so we are obviously a big contributor for the Cassandra community as well. So we believe that, and I think there's a lot of benefits for that for us. So of course it has been designed for this highly transactional, real-time information. So when you want to have high availability and a huge amount of transaction, like payments, stock information, IoT data, fraud detection, real-time recommendation, those kind of use cases, I think that are very good, like a good sweet spot for them.
Sounds like a good match for what we're trying to do today.
Yeah, definitely. And so let's go to streaming example stock. And I was watching the wrong screen. So there's a tab called Syncs. So I can create I can show using the same database that you are using for accessing the data. So we already have it here, one that is ready, but I can show you how we created that sync. So let's the default, that's the namespace that you could define your own name, but we use the default namespace over there. Then you can choose sync type. In this case, we are going to sync the data into AstraDB. And of course, you could put this in a similar fashion, send it to Snowflake as well for your data analytics.
And I can see like there's Elasticsearch, JDBC, there's pretty much anything.
Exactly. And there's a lot of experimental like support as well, and more is coming as we speak. So, but let's just put that as example. And connection topic. Input topic, this is a stream that you just produce with your application. You can choose then which is the database. Let's use that. We have now created 2 databases in this region, so you choose which one it is. Let's say I need a token. This would be now the AstraDB token. And I'll just memorize it or cut and paste it here. What it means, then it connects actually to the database, so it can retrieve now the key spaces that you have defined over there. So it stocks, and then this matches now the stock price POJO that you have in your application. So there's a table name, so that needs to match here. And once we have the token, it shows you, it automatically maps the streaming message values into the database values. So
this is pretty cool. I didn't know this before, but it was like just worked somehow.
It just works, but if you would have some custom names or you would need to do some fancy stuff, you can certainly do that mapping. But out of the box, it just works. And then when you create, it creates this sync, and then you're done. And for the demo purposes, let's now try to enable that sync again. So let's take that one. So as you can see, you can stop, you can start and restart them. You can access the settings and even see some log files. If something's not working, you can access this one and see what's going on. But let's put it start. It takes a little bit before it ramps up again. But after this is done, now you should have then the connection that it automatically persists that streaming data into your database.
Are you feeling confident that we can try it out now?
Yes, almost. Let's see. let me see.
While it's spinning up, let me
initialize.
While it's spinning up, just kind of quick review again of what we have. So we already configured Cassandra in the first step, so we already have that there. And then because we are in a Spring Boot application, it's pretty straightforward. We have mapped a stock price to a table like this, and then we have
and it's running, by the way.
And then we have this Cassandra repository, which is from Spring Data Cassandra. So with that amount of code, we were able to kind of map
and today
to the database essentially.
Today we didn't spend that much time on this database because this probably would be more typical use cases anyway. So
anyway, so we have now a repository for where we can pull this data, and we have a service that exposes just a few of those things to our view. So I have this other view built in here called stock details, which is a table view. And if I select a component, it will now show data that was put in there by this by this stream. So did we have one that was maybe empty from the start that we could show how it actually goes in there?
Yeah, it would have been a good demo to show the starting point. But you had a couple of stock prices that was not persisted. So let's see if those.
So if we go back to Amazon here, you can see that we have now a whole bunch of this stock data here. Again, if we take a look at how this is created, that's the wrong one. Let's go back to the details view. The details view again is a Vaadin Flow view extending from vertical layout. And we have a few things here. We have the text here on top. We have a selector for selecting these components, and then we have this grid. The grid is a Vaadin grid component, which is typed with the stock price type. And then we define columns by just saying like, hey, we want to pull the time out of stock price, give it a header of time. We want it to be auto width and sortable. And then we do the same thing for the stock prices here. The reason I'm doing decimal format here is because the API returns doubles, and we had some kind of weird double formatting, like some were with 1 decimal and some were with 3 decimals, and it kind of looked odd. But that's a good chance to just show how we can kind of customize what's getting shown in the
exactly.
And these are all sortable, so we can sort these like by time or by high or low or whatever price we want. And then the other part here is the selector here. So we're using the same selector that we had. And in this case, when we get a value change, we call our stock price service to find all by the ticker. The ticker is what we get from getting the value from our combo box. And this then differs all the way down to that Cassandra repository to fetch that. So again, we were able to just use kind of stuff that was provided to us by Spring Data, by Spring Boot. Like there wasn't a whole lot of like extra code we had to do to make this happen, which is what I think is really cool. Like we were able to get a lot of stuff done with not a whole lot of code.
Yeah, it actually looks way too easy to tap into these both the streaming and then the database entities.
Yeah, exactly. So just to kind of, I think the key takeaway here is that because DataStax builds on these open source, well-supported technologies that work well with Spring Boot, and because Vaadin builds on Spring Boot, it's super easy to kind of combine all of these and build just a very meaningful application in not a whole lot of time.
Yeah, and we call this our platform is open DataStax. So bringing all these open source components together in a very effective way, then this is what you get.
Yeah. All right. So let's, I guess, wrap this up. I think this is another cool feature that you wanted to mention.
A couple of words about the Stargate API gateway as well. So now we've been focusing and showing how you can access all this data using the Spring Boot stuff. But in enterprise, it might be that you have not everybody is Java developers, and you want to access to the same data using different methods. And I think this is very unique as well from our side. So Stargate IO, it's open source as well. So that's something that you can use on your Cassandra clusters today. But what it does is that it provides you multiple different interfaces for interacting with this. So you can use GraphQL, REST APIs, gRPC to connect that data. And it depends again on your application or microservices use case that you want to build, which interface you probably want to work with.
Yeah.
And the benefits of then having one of the answers why we are using Cassandra, because it can support the different data models as well. So with the CRUD, you're typically working with column family, but you can have a document APIs as well, and that kind of entry to the same data model. Schemaless, again, you just dump the data document into a database and then reuse it later on, and so forth. So I think this is a very, very valuable asset for someone else. And this is, we also, although we didn't today talk about these different ways how to do it, But sharing just information, if you will be using some Spring Boot 2.7 application, or even though you wouldn't use Spring at all, you can access this Stargate without it. But in a Spring application, you can access Astra or access this DevOps API. So you can use DevOps API, for example, for managing. You don't need to go to our console.
Yeah.
And we have a command line interface as well, where you can administer those databases and streaming instances. And there you see the different API REST, API document, GraphQL, SQL, and gRPC clients as well. So that's available as well. If you would then might need to do some complex work with streaming or Cassandra, that probably could be hindered by the kind of a built-in support from Spring Boot. So yeah, I think that's it. And the last slide for me would be that there's a lot of just leaving this here for a while. So there's instructions or advice then on how to use, for example, the command line interface. So that's creating a database that's more convenient. And if you want to check whether your stock information got to the database easily as well, you can use your command line as well to check that.
Yeah, and I think one of the questions we had come in is if we can share the GitHub link, and that is the first link here. So
yeah, you can find that there as well. And then if you're interested in Cassandra, academy-datastax.com, a lot of information on how to work with Cassandra, how to do the data modeling. NoSQL, it has a little bit on rules in that sense. And then bunch of materials available in YouTube as well.
Yeah, perfect.
That's from my side.
All right, thank you, Sami. All right, so before we wrap up, we have some time set aside for Q&A. We had one question about the GitHub link that we hopefully answered. We're gonna send that out in the email, and I'll put it up on my Twitter as well. So if you wanna check that out, I'll share the details in the last slide as well. Other than that, we don't have any questions. So do you have any questions for me, Sami, or should we wrap it up?
Yeah, well, a random question. Well, I mean, you have a Hilla as well, right? And then probably accessing from Hilla type of project, would you see the REST APIs, or how would you access similar?
So in Hilla, we would probably still do pretty much what we're doing right here, because it's a kind of a full stack application, kind of a backend for front end type of architecture, where essentially the front end team owns the topmost layer of the backend, essentially able to kind of define their own APIs that they need for their UIs, and that allows them to work really kind of move quickly because they don't have to like wait for other people. So we would pretty much do the same. You could access the REST APIs directly if there's some reason why you want to. So it's very flexible in that sense, but you would be able to kind of leverage all the same things here.
Yeah. Okay.
All right. We did get a question in. So why Pulsar? How is it different from Kafka? So you touched on this a little bit earlier, but just a quick recap maybe.
Yeah, maybe just providing that, well, it has a lot of, the biggest change is it's cloud native. It's built using the microservice structure as well. So you can, it provides better scaling possibilities. For example, geo-replication. If you would be having a Kafka installation, you would be distributing then your solution globally. Then you would need third-party tools then to provide that same latency then in Asia than in US, for example. Whereas Pulsar is designed from get-go to support better in these kind of scaling. And then the message deliveries and these kind of features is something that sets that apart.
Yeah, but from a use case perspective, they're more or less similar, or is there?
Yeah, I mean, initially, I think they're similar in use cases, and I think also if you would be using a DataStax platform, organizations have a lot of Kafka infrastructure already, so it would not be a question should it be Pulsar or Kafka. So you can combine these. So you can, like we showed, you can have a Kafka stream coming into the Pulsar and then process that within our platform. Then if you want to, you could then push that back into your Kafka infrastructure as well.
Yeah.
But maybe if you don't have Kafka and you're thinking about whether you should go with Kafka or Pulsar, then please take a look at the Pulsar benefits and do your own research, which one would be better for your use.
All right. Perfect. Well, let's wrap up here. if you want to reach us after the fact, you can reach me at Marcus Hellberg on Twitter and most places. I put your Twitter handle there without asking you, so
thanks. Yeah.
so you're welcome.
I need to start using and reading it more frequently now.
Yeah, and yeah, so just feel free to reach out. Like we said, we're gonna make the recording available. If you were signed up to this, you're able to also just replay the recording. What else was I about to say? You can probably turn off your screen sharing. I will help you. There we go. All right, and I did figure out what was going on with the camera. It was overheating for some reason, so I need to figure that out until next time. But thank you so much, everyone, for joining us, for sticking through the webinar, even though we had some technical issues. I think what we ended up building was really cool, and we'll share the link to that so you can get started, just play around with it yourself, and just let us know if you find anything like cool, interesting. If you have any questions, you can put them in like GitHub issues and stuff on the repo.
Yeah, please approach if you find any of those.
All right.
Thank you.
Thank you. Bye.